Hello and welcome back to Compiler Programming. Over the last couple of weeks I was working on increasing the support of Linux, and if we look right now at the tests, we can see that there is some sort of complicated stuff here, but mostly the tests that are disabled on Linux are the tests that require actually interacting with the operating system. So both this relocation test and this FizzBuzz is relying on ability to sort of write stuff out to the standard out and also to exit the program. So in order for that to happen, we need one of two things. We either need to be able to do syscalls, which is something I will do in the future, or we need to be able to do the same thing that we do on Windows, which is open system library, so libc in the case of Linux and Mac, and just call some functions in libc. Now, in order to do that, we need to fix this to do, but before we do, let's actually write a test. And not sure what would be the good place for it. Let's just stuff it here for now, and then we'll see where it goes. So it should be able to print out a string. Okay, so how does it look like? Well, we need to copy something from here, so I don't have to write it from scratch. Let me find something that is nice and good. Well, this will do, I guess. Doesn't really matter what we are doing here. Okay, so we have a function, and it somehow needs to interact with the system. For that we need external, and we can copy one from here. Of course, I need to change it to be a function, and we will call it write, because that's the name of the wrapper function in libc for the raw syscall in Linux. So that's what we're gonna use, and the type of here will be the descriptor, which is S32. And then we have basically a pointer to U8. I actually have a new syntax for pointers. I'll go a bit into detail and plans for this in the other video, but for now, just to explain this. And then we have size t count. Okay, great. And actually it returns indeed an S64. That's correct. That is a size t. I probably should define actually C types so I can use them directly here. I'm not sure. Maybe it will be a library or something. Anyhow, we need to say size. So this is like buffer, and size is U64. Okay, let's split this into two lines so it's easier to read. And in external, it is going to be a bit awkward because I'm actually not sure yet exactly how to handle this. I'm not a Linux user by any stretch of imagination, and I'm not super familiar with how I should be managing the dependencies on dynamic libraries, but I'm sure that on my Ubuntu the libc is available under this name, so that's what I'm going to use, and we'll figure out all the other operating systems later or how to do it dynamically. If you know any pointers, leave them in the comments below. I would be happy to learn about that. But for now, this is what we are doing. So we're saying that this is a function that will have this signature, and then it will be loaded from the libc, and we are looking for the function with the name right, so this function. Great, that should be pretty straightforward. And then we are calling this, and I will not require any arguments. That's not the point of this test. What we want to do is we just want to have something on the screen here. So let's try to make that happen. We just call checker, and we should not crash, ideally. Okay, and this will do right, and then right, another thing that we need is we need to have a file descriptor, so something that we can pass here, and it's actually not the same file descriptor as the one that is used for things like fwrite or fopen in libc. This is a kernel descriptor, and to figure it out you need to look here, and they are technically defined in stdio.ih, and we can use them here. So it's just numbers 0, 1, and 2, and we want std out, and std out is number 1. So let's define a constant that is going to be exactly the same name, so std out file no, and that's going to be 1. Great, so we're gonna use this constant here, and then we're gonna pass something like, well, let's make the test nice to look at. So we will have here the string hello, and hello is going to be just saying hello world. Okay, and we are gonna put hello bytes and hello length. Okay, that should be fine. And now ideally, if everything goes right, we will just get a crash with this assertion over here to do support DLopen on Linux, but let's see. And apparently we do not, which is very interesting. No, we do, yes. Here's the assertion, exactly where expected. So that's actually good news. That means that the file was parsed just fine, and only when we tried to run it, it didn't really work. Okay, well, let's start working on this stuff. First, we'll need to, I guess, include something. Yes, so this is the header that we need. Let's put it the way at the top. We already have something here for the memory management. Now we are adding something for opening files. Right, and we also need to change the link. Okay, so build sh minus l ldl. Okay, ldl, and I probably need to somehow dedupe this, but okay. So we linked that. Now we need to actually work on this. So let's uncomment this code, and it's mostly gonna stay the same. The only difference is we were using this load library thing on Windows, and now it's gonna be something else on Linux, and that something else is DLopen and DLSim. So DLopen is equivalent to this load library A, and loadsim is equivalent to get proc address. I might even be able to extract this code later into something better, but for now let's just stick with this. Maybe I need to change something else, and I'm not aware of that. Okay, so DLopen goes here, and we, unlike Windows, we actually need to provide some flags which are described over here. From what I understand, I want to have lazy loading. So if I'm loading a library, I don't want to load all of its symbols right away. I just want to load ones that are interesting to me. So that's something like this. And I don't think I need to do any of that. The global is the default, if I understand correctly. So it should be fine. But I guess we'll figure out if something goes wrong. Okay, so DL open. And here we have DL sim. Right, that's fine. We check the address. We put the address in here. Well, that looks pretty much that, so maybe it will be a rather short video, or maybe we'll run into some issues right now. Let's see. Let's try to run test.sh. And I'm using the wrong slash. I said test.sh. Okay, so that's no good. Right. I need to somehow set up my editor so it can build on Linux, I guess. That's gonna be interesting. But right now you are unhappy about the allocator. Well, whatever. I'm just gonna put allocator default and me click. I'm not gonna deal with that right now. I need to pipe here. I already did a change where I added a temporary allocator that is sort of global to the whole compilation, but it's just not available here yet, and that's something I need to fix, but that has completely nothing to do with what we are trying to achieve at the moment. Okay, that's promising. And here we are. So that was pretty good. I mean, I expected to run into some issues, but apparently that's all it took, which is also nice for a change. I guess let's add a new line so that is nice and tidy here. And we also probably will need to separate this test to only run on Linux right now. I'm not even sure it will work on macOS, but I need to get my laptop out, and I will not be able to show it in stream anyway. Maybe I should also figure out some way to like remote desktop into macOS when I'm gonna start working on it more thoroughly. But for now, that is basically what I want. We are able to print out a string. I should be able to do something like this here. We will need to say, is it like POSIX? I always forget. How is it here? It's called Linux. Okay, if defined Linux, great. So this is what we want to do, and that should allow me to run this code on Windows as well. So actually not run it on Windows rather. Okay, that is perfect. Basically, that's all. So to recap, now we are able to define these functions. We are able to define that they're external, load some library. It will be automatically loaded into JIT environment, and we can JIT run functions that call native functions, which is great. Okay, that's all I wanted to do for today. Thank you very much for watching, and hopefully see you next time.